Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Let's continue our assessment for paper 2 about refraction. Now we have question 9. Light is traveling through air. The light strikes a glass block at an angle of incidence of 45 and the refractive index is given. What is the angle of refraction? Okay, here I will draw and explain to show you how you can make sure that your answer is realistic, and you have to draw a boundary here. You have to draw normal to the boundary. Okay, the angle of incidence is 45. The light is traveling from air to glass, from less dense to denser. What happens to the light ray? It will not continue in a straight line. It will be deviated or refracted or bends towards the normal. Towards the normal. Okay, so the angle of incidence is 45, and the angle of refraction, you have to calculate what is the numerical value of the angle of refraction, but for sure it's not 82 because it should be less than the angle of incidence. Okay, let's try to apply Snell's law to calculate the angle of refraction. Okay, the general formula for Snell's law that n for the first medium sine theta 1 is equal to n for the second medium sine theta 2. Okay, the most common one used when we are using Snell's law, if one of the two media is air, we are using this one, which is n for the medium is equal to sine angle of incidence in air divided by sine angle of refraction in the medium. When you apply this, so you have the refractive index is 1.4 and the angle of incidence is 45. So cross multiplication, you can find that sine 45 is equal to 0.707 divided by sine r. Okay, cross multiplication, sine r is equal to 0.707 divided by 1.4. The answer is 0.505. Shift sign your answer. You can find r. The answer is 30 degrees. Okay, again, one more time, only the final answer should be rounded. So here, if you have sine any angle, the refractive index also, if you have, for example, two different media, one of refractive index 1.42 and another one 1.43, so they are two different media, they have each one has its own refractive index. So approximation here is not allowed. You have to keep the numerical value as it is. Okay, and again, if you have any angles, please, if you have any values for sine or cosine, you have to only allowed to round the final answer. Okay, so the answer is B. The answer is B. I have to check also question 15 is very important. So no need for this. Okay, I will move to question 15 is very important, this one. Question 15. The diagram showing a ray of light incident on the surface of a rectangular glass block. How this light ray will behave? This light ray strikes the rectangular block at an angle 90. At an angle 90. What happens here? It will continue in a straight line. Okay, without any deviation, without any refraction. So what happens here at the boundary? The angle of incidence is equal to 0. The angle of refraction also is equal to 0. Does it mean that refraction will not take place? No, there is refraction, but no change in direction. So what happens inside the glass block? Inside the glass block, what happens? The speed decreased and the wavelength of the light ray will be decreased inside the glass block. And what is kept constant is the frequency unchanged, and in this case also the direction will not be changed. Direction also unchanged. So the two features here remain unchanged, or direction and frequency.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor.